So now I'm going to be working to solve the question, in what year will the value of $300 be equivalent to the value of $10 in 1915? So we're just going to be plugging some values in to this equation and then solving for the unknown values. So in the question, we're given the monetary amount, and we know that that is our y value. So we put that for y. Now we don't know x, which is the years after 1915, so that's the value we're going to need to be solving for. So the first step in the solving process is, in isolating the variable, to divide both sides by 8.902. So we do this and we get 33.700292 equals 1.032 to the power of x. Now, in order to free the exponent, we're going to take the logarithm of both sides. And then, using the power of logarithms, we can move the exponent from here over to here, because we know from our properties that those are equivalent by the power of logarithms property. So then, in order to solve for x, we can divide both sides of the equation by log of 1.032. So then we get x equals log of 33.700292 divided by log of 1.032. And then that comes out to x equals 111.67. So remember, the x value is equal to the number of years after 1915, and the question asks us in what year. So thus, we add this value to 1915, and we find that the value of $300 will be equivalent to the value of $10 in 1915 in the year 2026. And then we can verify this graphically. Here's the graph of the dollars, and then we put in the y equals 300, because we know that y does equal 300, and find the intersection. And that's at a 111.67, which was the ultimate answer we got for x in our problem. So now we have a similar problem, but for pounds, and so we're going to solve it a similar way. Y equals 300, we divide both sides of the equation by 1.148 and get 261.32404 equals 1.051 to the power of x. And then again, we take the log of both sides, and then again we can move x to the front right here. And so x equals log of 261.32404 divided by log of 1.051. And when we do the math, we get x equals 111.89. And so again, we need to add that value to 1915, and we get that the value of 300 pounds will be equivalent to the value of $10 in 1915 in the year 2026, which, if you recall, was the same year that we got for the previous problem. And here's the graphical verification, y equals 300, and here's the graph of the pounds, and here's their intersection. So, now we're going to do one last part of the problem, and that's to do a similar question but for the value of Canadian dollars. So again, y equals 300, divide by 8.050 to get 37.2671 equals 1.033 to the power of x. Take the log of both sides, move the x to the front, and so x equals log of 37.2671 divided by log of 1.033. And thus x equals 111.44. So again, the value of 300 Canadian dollars will be equivalent to the value of $10 by the 1915 value in the year 2026. And here's the graphical verification of that. Here's the Canadian dollars, y equals 300, and they intersect at the point 111.44300. So, what this means, because we got the same value for each currency, what this means is that the graphs of the three currencies would intersect right around the point 111 for the x value, 300 for the y value. So now here is my works cited, and this is just the Precalculus book, which I referenced for some of the math techniques. And then this is the graphing calculator that I used to find the graphs. And then these are all sources for my data, and these are also sources for my data. So that's all. Thank you for watching.